For today's lesson, we're talking about how to take what you've learned with linear equations and apply it to different real world scenarios. And so we're going to do a couple examples so you can see at first kind of how it relates to real life situations that you probably will encounter as you move through life. And then we're going to start slowly relating it to what we've been talking about with linear equations and how it relates to slope and how it relates to the y-intercepts. Okay, so let's get right into our equations. The first, or our example, excuse me. The first example says you are out looking for apartments and find 3 different places that will work for you. Okay. And so my best advice when it's kind of presenting a whole bunch of information for you is to either underline or highlight the information they give you. Okay. So that's what I'm going to do as I go along. It says the first apartment is at Beautiful Views. It says it requires a $500 deposit and then the rent is $475 a month. So because all of this kind of goes together, I'm going to highlight all of that kind of in one thing. Okay, so that's Beautiful Views. You're going to have to deposit $500, which is kind of like, I guess, to hold the apartment for you. And then they're going to charge you $475 every month to just live there. Okay, the second apartment is at Pleasant Valley. It has no deposit, so you don't have to put any money down, but the rent is $500 a month. Now, if you had different color highlighters, I would recommend maybe highlighting each, or the different apartments with a different highlighter. I do not have a different color, and so I'll have to highlight it with my yellow one. But that is a way to organize your information so that you can tell the difference in each apartment complex. It says the last apartment is at Cedar Springs. The deposit is $900 and then the rent is $400 a month. And so that's the last apartment that you're looking at, okay? It says describe all 3 possibilities as linear functions. And then it says if you plan to move in 6 months, where should you go? What if you live there 1 year or 5 years, okay? So what we're going to do is we're going to write down an equation that represents how much we would pay, like in total if we're living at each place. Okay, so let's start with our first one. So Beautiful Views, notice I just put a BV to represent Beautiful Views. It says it requires $500 deposit. So that's what you're going to pay initially. Like if you, in order to actually, for them to hold the apartment for you, they are going to have to pay you, or you're going to have to pay them $500. So that's like a one-time fee that you'll pay at the very beginning. And then you're going to pay $475 for each month. Okay. So if I wrote that as an equation, you're going to pay $500 initially plus $475 every month. And so you're going to take that number and multiply it times however many months you're going to have that apartment. Okay. So kind of relating this to what we've been talking about with linear equations, whatever that initial thing is that you're paying, that is your y-intercept. Notice and it's kind of flipped around here. Eventually, we'll flip it so that it looks like it normally looks in slope-intercept form. But whatever you pay initially is going to be your y-intercept. And then whatever it is you're paying per, in this case, we're paying this per month, that is your slope, okay? So that is an equation to kind of figure out how much you would end up paying total based on however many months you have the apartment. Okay, so then keep going. Pleasant Valley, it says it has no deposit, but the rent is $500 a month. And so if I kind of thought about that, I'm going to go to the side. If I thought about that, I wouldn't put anything down. So it'd be 0 deposit plus I'm paying $500 per month. So it would be 500 M. Okay, so the reason why I put that to the side is because I'm not having to put any money down. So this is like 500M plus 0, which is just going to be 500M. So I just have to worry about paying $500 a month if I lived, or if you lived in Pleasant Valley. Okay, the last apartment complex that you're looking into is Cedar Springs. So Cedar Springs, you have to put a $900 deposit down. So you're going to have to pay $900 originally. And then you're going to have to add to it, you'll have to pay $400 for every month. Okay. So it would be plus 400M. So those are linear equations that will help you find how much you would pay for that apartment complex, or for the apartment, to be able to rent it for however long. Okay, so what we're going to do is find how much would we end up paying for if we lived at each place after so many months, or even if we stayed there for years at a time. Okay, so what if we just had the apartment for 6 months? How much would we pay for each one? Well, if I lived at Beautiful Views for 6 months, remember, you'd have to pay the $500 deposit, but then you're going to have to pay $475 a month. So what I would do is I would take this equation and I would plug a 6 in for M. Okay, so if I did that, and I'll go to the side and I'll do that, I would take 500 plus 475, and then I'd have to multiply it. I'm going to stay there for 6 months, so I'd have to multiply the 475 times 6. So you could just type that in your calculator, and when you did that, you would end up getting, after 6 months, you would have paid $3,350 to live at that apartment complex. Okay, well, what happens if instead you lived at Pleasant Valley? Well, Pleasant Valley, you didn't have to make a deposit, but you have to pay, notice, a little bit more per month. So let's see how much you would have to pay if you lived there. So you would take 500 times, and the number of months you're living there would be 6. So it'd be 500 times 6. And so when you did that, you could just type it in. You would end up getting $3,000, or you would end up paying $3,000 after 6 months. So comparing these two, it would be cheaper to live at Pleasant Valley than at Beautiful View. So let's check out, well, what if you lived at Cedar Springs for 6 months? Well, if you lived at Cedar Springs, you would have had to made a $900 deposit, and then you'd be paying $400 a month. So you would take 900 plus 400, and then you'd again plug in a 6 right here because you're staying there for 6 months. And so when you did that and you typed it in, 900 plus 400 times 6, you would end up getting $3,300. So if you lived at Cedar Springs, you would end up paying $3,300 for 6 months. Okay, so, well, if you just lived there for 6 months, which place would be the best? Okay, well, if you live here, you'd end up paying $3,350. Here you'd pay $3,000. Here you'd pay $3,300. So which one's the best value? Well, Pleasant Valley would be the cheapest. So if you lived there for 6 months, you definitely want to stay at Pleasant Valley. Well, what happens if you lived there for a year, or if you lived there for 5 years? Would Pleasant Valley still be the best value? Well, let's see. So if I lived there, or at each one for a year, okay, remember in this equation, we're paying per month. So what you would have to do first is figure out how many months are in a year. Okay, and you can think through it, or you can count the months, January, February, March, so on and so forth. But you would figure out that 1 year is actually 12 months. And so what you would do is you'd go through to each equation, and when for M, you would plug in 12. So if I plug in 12 here, it'd be 500 plus 475 times 12. So if I did that, I get $6,200. So if I lived at Beautiful Views for 12 months, or same thing as a year, I'd end up paying that overall. For Pleasant Valley, I'd plug in a 12 right here, and if I did that, I end up getting $6,000, so I'd end up paying $6,000. At Cedar Springs, you'd plug in a 12 right here, and then after you typed that in, you would end up getting $5,700. So if you lived at each one of these places for a year, this would be how much you would end up paying at the end of it, or at the end of that year. So which one would be the best value if you decided to live there for a year? Well, which one's the cheapest? And if I'm looking at it, if I lived there for a year, Cedar Springs would actually be the cheapest. So notice, these numbers can kind of play around with you, but when you actually kind of figure it out, you'll figure out that different amounts of time, depending on how long you wanted to live there, it's going to kind of give you different values because, like, notice you're paying different amounts per month, and that will make a difference. Okay. So in this scenario, if you live there for a year, Cedar Springs would actually be the cheapest and the best value for your money. Okay, so then what if we lived there or decided to live there for 5 years? Well, again, these equations are based on months, and so you'd have to figure out how long in months 5 years is. And so you would take, well, each year is 12 months, so you'd have to take 12 times 5, and you would get 60. So really, you're kind of trying to figure out how long or how much would you pay after 60 months. And so again, you'd take the 60 and you would plug it in for M in each one of these. Okay. So if I did it for the Beautiful Views, I would end up, I would end up getting that I would have paid $29,000 at the end of the 5 years or the 60 months. If I lived at Pleasant Valley, so I took it and I took 60 and plugged it in for M in this equation, I ended up getting $30,000. And then when I plugged the 60 into this equation, I ended up getting $24,900. So if I lived there for 5 years, which one would be the best value? Well, which one's the cheapest? And so if I'm looking, this one right here is the cheapest. So if I lived there for 5 years, Cedar Springs would still be the cheapest or the best value. So if you live there for a year or 5 years, you would want to stay at Cedar Springs. If you live there just for a short amount of time, it's looking like Pleasant Valley would be the cheapest. Okay, so that's how you can use linear equations to kind of find, I guess, a good value for your money. Okay, and that's often the case, is you can look at the equation to find good values of things. All right, so other questions that they could ask you, it says, how long could you live at Beautiful Views if you only had $9,050? All right, so it's asking about Beautiful Views. So if I do that, well, I'm going to take the Beautiful Views equation and I'm going to copy it down. And they're saying, they're wanting you to act like you only have this much money. Well, if that's all you have and you're trying to stay there as long as you can, that's actually what you're going to set the equation equal to. So we only have $9,050 to spend on the apartment. How long would I be able to stay at this apartment complex if that's all I had? And so you set the equation equal to that, and then you solve it. So what I'd have to do first is I'd have to subtract my 500 to each side. And so after I subtract my 500, and I'm going to have to come over here because I ran out of room, I get 8,550. And then that equals my 475 times M. And then from there, I would divide by 475 on each side. And after I do that, my M would equal 18. So how long could you live at Beautiful Views if you only had $9,050? Well, notice M equals 18. And so M is the number of months. So you would only be able to stay there for 18 months, which is the same thing as 1.5 years. So you'd be able to live at that apartment complex for 1.5 years if that is what you had money-wise. Okay, so I want you to try this problem. Okay, so see if you can figure out how much you would spend in this scenario for different lengths of time. And then I want you to see if you can answer that question. All right, so if you set up your equations for this, you'll notice you would have highlighted the blue van. You wouldn't have put any money down, but you'd have to pay $250 a month for it. With the red truck, you would have had to put $1,000 down, and you'd only have to pay $199 a month. And then for the black convertible, you would have put $500 down, and you would have paid $225 a month. Okay, so the equations, and it depends how you wrote it, but I'll just put BV for black, or excuse me, for the blue van. So for this one, you didn't have to put anything down, but you had to pay $250 a month. With a red truck, so I'll put RT for red truck, you would have had to put $1,000 down, and then you'd have to pay $199 a month. Okay, so that would have been the equation for that one. And then for the black convertible, so I'll put BC for the black convertible, you would have to put $500 down, and then you would pay $225 a month. Okay, so to find how much you would have paid after each time frame, you kind of do the same thing you did in the last problem. So notice you're paying per month here. So these equations are going to tell you how much you would pay in total after so many months. Okay, so if I was if I was only going to have this car for a year, well, how many months is that? So every year is 12 months. So what you would do is you would take 12 and plug it in for M in each of these equations. So if I did that for the blue van, I would end up paying $9,000 total for that year, or to have that van for a year. For the red truck, I would end up paying $8,164. For the black convertible, I would have ended up paying $8,600. So if you only had the car for 1 year, which one would be the best for your money? Well, which one's the lowest here? And it looks like the red truck would be the best one for your money to have just for 1 year. Okay, well then what if we instead decided to keep it for 3 years? Oh, I think I got these mixed up. The 3 years would be these values. I'm sorry, I'm going to have to fix this. I think I had my columns mixed up. I'm sorry about that. So we'll just write the 3 years. For the 3 years, well, how many months is 3 years? I'd have to take 3 times 12. So 3 times 12 ends up being 36 months. So I would come in here and I would plug in 36 for these. And so, yeah, I don't know why I didn't catch that earlier. So if I plug in 36 for M here, it would end up being, yeah, I had these switched around. So for 3 years, I'd end up paying $9,000 for the blue van, $8,164 for the red truck, and then $8,600 for the black convertible. And so for the 3 years, fixing myself here, which one would be the best value? Well, the red truck is the cheapest. So if I was keeping it for 3 years, the red truck would have the best value. So now let's do the 1 year. So if I kept this for 1 year, then which one would be the best value? So now I would go in and plug in my 12. And so when I plug in 12, I end up getting this one to be worth $3,000. The red truck would end up being $3,388. And then the black convertible ends up being $3,200 that you would pay throughout that, or for the whole year, to keep the car. So if you only had it for 1 year, which one would be the best value for your time that you've had it? Well, which one's the cheapest here? And it looks like the blue van would actually be the better one for your time and value wise. So if you only kept this for 1 year, the blue van would actually be the best one to buy. Okay, so then what about 5 years? Well, figure out what that is in months. So 5 times, well, there's 12 months in a year, so it'd be 5 times 12. So that ends up being 60 months that you would be paying for that vehicle. So if I plug 60 into these equations, well, for 250 times 60, I would end up getting 15,000, or I'd end up paying $15,000. For the red truck, I'd end up paying $12,940 throughout the 5 years. And then if I bought the black convertible, I would end up paying $14,000. Okay, and so again, all I did is I just plugged in 60 in for M, and in each of these equations, and that's what I've got. So if I pay for this car over the course of 5 years, then how much would I end up paying? And which one would be the best vehicle for my money and my time? Well, which one's the cheapest after 5 years? And that looks like it's the red truck. So if you have the vehicle for 3 years or more, it's looking like the red truck would be the best value for the amount of time that you can use it. Okay, so just looking at equations, kind of learning how to compare numbers here. All right, so the next one says, how long could you own the black convertible if you only had $5,900? Well, you're looking at the black convertible, so I'm going to copy down the equation for how much I would pay if I bought the black convertible. And if I only have $5,900 and I'm trying to keep it as long as I can, that's actually how much I would be paying. So that's what you set the equation equal to. So if I only have $5,900, how long could I keep it? So you take the equation and you set it equal to the amount of money you have. And then you solve it. So I would subtract my 500. So after I subtract 500, I would get 5,400 on this side equals the 225M. And then you would divide by 225. So after you divide by 225, you end up getting 24. So how long could you own the black convertible if you only had this much money? Well, the M stands for months, so you would be able to own it for 24 months. Okay, before they would either have to take it away or you'd have to sell it to maybe purchase a different car. Okay, so now we're going to start relating it to what we've been talking about. So remember, when we talked about slope's the same thing as like the rate of change. Okay, so the way that you can think of this is it's the change per something. So like in these problems that we just did, it was how much you were having to pay per month. So like if you were renting an apartment, you were having to pay a certain amount of money per month to be able to rent it. If you were buying a car, you were having to pay so much money per month to keep the car or to pay for the car. And so you can think of it as change per something, or you can think of it like we've talked about it before. It's the rate that something is changing. Okay, so the rate that something is changing, which is rate of change. Okay, so some examples of what we've talked about was like in the renting problem, and then the problem we just did with buying a car, it was money per month. Okay. Or some other problems that we've talked about, you could be talking about traveling down a road and you could say miles per hour or like cost per ticket. Those are all slopes. So the thing that you are doing on a monthly basis or the thing that has to be done on a regular basis, the thing that's changing, that is your slope, okay? So the y-intercept in these problems, remember I had talked about like the deposit in this problem up here was what you do initially, and that is your y-intercept. So whatever it is that you do initially and then you don't really have to do over and over in these problems, that is your y-intercept. So the y-intercept in real world problems is like your starting amount, or you might also hear it's your initial value. So starting amount or initial value. Okay. And so in these problems, but then also in like a graph sense, it's also the amount that you have when x is 0. So a lot of times in real world problems, the x values is kind of like your time. So you'll hear me talk about it's the amount that you start out with at time 0 before any time has passed. Okay. So like in these problems that we just did, it was like the deposit that you put down for the apartment. Or like in the when you were buying a car, it's the money that you put down for the car. Okay.